How's it going, everyone? We're going to be starting in just a second here. We'll be going over some Project Euler today. It should be pretty fun. If you love coding and some simple little math challenges, at least at the start, then this is a good place to be. Okay, let's start to get things going. How's it going, everyone? My name is Zane. I am a coach and streamer here at MLH. And today we are going to be doing stuff with Project Euler. Curious if anyone in the chat has experience or at least has heard of Project Euler before. It's nice. You have some like math, coding challenges. Starts out pretty simple at first, but it gets a little bit intense as you get further and further along in them. I myself have looked through them a little bit. Haven't really tackled them before. I thought it'd be pretty fun for us all to jump into this together. So it's a fairly well-known intersection between math and coding to just help people level up their skills. So, well, without further ado, we'll jump into it. With that, I have the event link here in the chats. So for all our viewers watching, just make sure to click on that link and check in for our event today as part of Global Hack Week. So with that, let's get underway with our coding and all. So let me jump in Windows a little bit here. I have the first Project Euler task before us here. So I can add this here. Here we go. Okay, so as we can see, I'll just walk you guys through the basics of it. This is let's go to the about. So what is Project Euler? A series of challenging mathematical computer programming problems that will require more than just mathematical insights to solve. So the intended audience includes students for whom the basic curriculum is not feeding their hunger to learn, adults whose background is not primarily mathematics but an interest in math. I don't know. It's just a fun way to incorporate both math and programming skills. Myself, just a little bit about me, I have been teaching myself math from the ground up since over the past year. I started all the way back at basic arithmetic just to be sure of what I'm just be sure that I didn't miss anything, that I forgot anything. So as I was looking into ways to learn, I found out about Project Euler, and I had talked to some friends about it. They looked into it. They heard of it themselves. They thought it was something worth tackling. So figured we could all partake in this together, have some fun with it, and see what we come up with. If anyone in the chat has any ideas or just insights or anything of the sorts within each of these problems, by all means, let's collaborate on it together. But let's see. I'm going to be jumping into this, not blind, but I've looked at the first few problems and the like. They seem pretty manageable. But just in terms of designing the programs, the nitty-gritty of it all, I haven't sat down and worked all that out just yet. I figured that'd be a fun thing for us to do here. Get our creative juices flowing, brain juices flowing, and just go from there. So with that, we have our first problem here, our first Project Euler task. We list all the natural numbers below 10 that are multiples of 3 or 5. We get 3, 5, 6, and 9. Well, the sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1,000. Okay, I'm going to have to think about that for a second. So find the sum of all the multiples of 3 or 5 before 1,000. So how do we want to approach this? In fact, let me take a screenshot of this. That way we can have this in front of us while we work out a way to resolve this. So I have my handy dandy Microsoft Paint open. This way we can get into our writing sort of note-taking mode. So here we go. So all the natural numbers below 10, multiples 3 and 5, we get these. So the sum of all multiples of 3 or 5 below 1,000. So how exactly do we want to approach this? So it's kind of like FizzBuzz in a way, if anyone's familiar with FizzBuzz. FizzBuzz is a simple programming task that, I forget the exact details of it, but I think it's that if a number is a multiple of both 3 and 5, so essentially what you do is that you generate the multiples of 3s, you generate the multiples of 5, and you have a program print them out. And if a number is a multiple of 3 and 5, you like print like a different words and something along those lines. So in order to do that, in order to do something like this, let's think about it. What do we need? Well, we need to generate the multiples of 3, generate the multiples of 5, and have a way to detect those and potentially isolate them as well, so that we can get the sum of just these numbers. Well, here, we could just do this. We could say, if we have, get big notes here. There we go. So the worst case thing to do, honestly, would be to like, not worst case, but I guess just a little bit inefficiently, would be to generate just all of the natural numbers and then like filter from that list of numbers. Just kind of seems like a waste of time. What we could do is generate at least multiples of 3 if we wanted to do like, say I is equal to 0, and then for each we can do I plus 3 until I is, while I is less than or equal to 1,000, something like that. So that would at least get us for 3. I guess we could do the same for 5. So multiples of 3 or 5. So that's the big thing as well, not multiples of 3 and 5. So we'll have to get both of these. But 2, so we want multiples of 3. So I guess there's kind of like 2 data lists here, right? Where there's 2 things of data. So list of 3, list of multiples, list of 5 multiples, and then a way to, maybe we could like filter an array, or we could send them both to an array where it's filtered out to where, because if we have these 2, if we have a list of multiples of 3 and we have a list of multiples of 5, well, there's all sorts of multiples of 3 that are also multiples of 5. We don't want to like double count them in the way that we add this all up. So how do we want to do that? We could do, let's think. We could just have it check for if like a value already exists within. So we could do this. We could say, we could create an empty array. So initialize an array. And we could like generate mults of 3, generate mults of 5. We could do like 3 times n, just for different multiples. And then we could, with logic, if we could iterate both of these, 3 times n dot, we could do like number, let's say if not, if n not in, let's say array. I don't know, I'm using some weird notation here, but I hope you can follow it. We have an empty array here. We could generate an array of multiples of 3, generate an array of multiples of 5. We could say for each value in the array of multiples of 3, if that one particular value is not in the array of, is not in the initial array, then we can simply add it to the array. Add n, something like that. And then we can do the same thing for the array of 5. Right, if n not an array, then we could simply do array.add n. So that's one way to do it. That should. So then once we have this array here that will have the multiples of 3 and the multiples of 5, then we could just do like a function, or we could iterate the array and just add everything together and return and find the sum of all the elements within it. So with that, I'm trying to think if that's like the best way that we could do it, like the most efficient way. That's the first way that comes to my mind, at least. Right, a few times. I wonder if there's a way that's better. I don't know. If anyone can think of it, by all means, please let me know. But here we have that. Let's try and build this in code now. So we have our notes here. Oops. Oh, it's cut off actually. Here, let's do this. Let's do text. Here we go. So this is kind of some weird pseudocode, but it'll kind of get us going. So now let's go to our code editor, and we will try and implement this. So share screen. We'll go to this here. Now put on a little bit of background music. Just kind of chill out. So, well, there we go. Weird. Okay, so anyways, so let's add here. So I have my first, see, this is my Python folder where I do Python files. Let's tackle these in Python. See, we have our first problem 1. I'm gonna paste in our idea for this here. We'll paste in the, so let's say method. Throw this in here. And can I, oh, I can't hold it, weird. Anyways, we have that. Then we'll keep the prompt for this up as well. So find the sum of all the multiples of 3 or 5 below 1000. We'll do that. This way we're just kind of grounded within it. Perfect. Okay, so let's try this out. In fact, let's do new text file. We can open this to the split left, split right. There we go. No, oops, split right on that. There we go, perfect. We'll close this out here. So find the sum of all multiples below 5 or 10. There we go. Oops. There we go. Okay. This here. Should like Alt Z this actually. There we go. Okay, perfect. So with that, let's just jump in with this. Well, actually, let's do that pi. Why not? That way it's properly formatted. Okay, so with that in place, let's start developing this. So we'll do generate the array of multiples of 3. Do multiples. We could do, I guess it could be a of 3. And I could just return like what do we put here? For I, oh, hold on. Oh. Okay. Annoying. Anyways, so we have multiples of 3. Then we can, I know we can generate this within the like within the function here, but let me, like, just within this array. There's actually probably a way to one-line this, but just kind of think through this. So if we do for I, actually, let's do some of my other projects. Oh, I wanted to find something that I could usually jump into. Nope. Suppose 3, we could say for I, actually, let me see. So for Python, generating numbers. Python loop. Here we go. So for I in range 0 to 1000, we'll keep it at that for right now. Let's say print I. Let's try this out. Let's just kind of test it. Oh, then we have to call the function, of course. There we go. There we go, perfect. Okay, so for I, range of 0 1000s, I guess we could do that, but really it should be, let's see, what does it say here? It says range step. Okay, so then we want it stopped by 3. So we'll do that. Perfect. Okay. So now I wonder if we could do, I know there's a way to do this, but I can't remember off the top of my head. We do this. No. There we go. Perfect. Okay. Yes, that's what I have in mind. So we can do that. Let's see. Got some stuff in the chat. Initialize an empty list. Here we go. Ajax on, or Jackson. Yeah, sum is going to be super, super helpful for just, well, getting the sum. It's a great little function for just taking iterable and being able to add everything like super easy. Multiples, right? Yeah. So we will. So I don't want to. Seems like you got a pretty good solution. I don't want to look into it too heavily right now. Once I solve this, we can compare and contrast kind of how we went about it. But yeah, I mean, if anyone else in the chat, by all means, if you have a methodology, if you have a way to solve this yourself, please. let's do it. So we can do return that. Oh, why is this? Oh, that's why. There we go. So multiples. Let's say generate multiples. There. We could say, I don't know, what would be the mathematical term for this? I don't know. Multiple base, I suppose we could just say. So with that, we could say generate multiples of 3 and of 5. Let's see if this works. And then 5. There we go. There we go. Perfect. So now we want this to be 1000. So there we go. Look at those big. There we go. Okay, so with that, now we can make an array that's basically, what do we want to say? Generate array, I guess. I don't know why it just sounds a little silly. Not the best name, but we can go forward with it. So generate array. So what do I want to do? Well, I'm sure Python has like a filter. Like my main programming language is JavaScript overall. Python I've been learning a little bit over the past couple months, on and off. But with that, I'm trying to think of the best way. What do we say? So we generate 3 and 5. So if not in 3, n in 5, I guess. It's like, do we want to iterate both of these one by one? Like iterate by 3 and then like add those to this like 1, right? Because again, we're going to have an array that's going to house the multiples of both this and of the generating 3 and generating 5. It's like, do we want that to, I guess it's going to have to iterate over the array of 3 first and the array of 5 second. You might be able to do it concurrently, but I don't know. As long as it gets done, I guess. So with that, I don't want to do it. Let's see. So for n in, I do that. That should work, right? I'm gonna get a lot of hellos if so. Yep, there we go. Perfect. Okay, so now we can do define. No, we can just say of 3 and 5 equals empty array. Or really we could just I feel like we could not one line, but like really make this, really kind of condense this down. Well, at least in here we could say multiples array. That's a lot better, I guess. Or just multiples. Multiples, we could say, well, let's just have it for now. If n not in multiples, we could say multiples dot appends n. And then that should be, then we could just print multiples after that. Yeah, because why would it not be? That would most definitely be destructive towards the array. Like in a good way. There we go, yeah, exactly. Okay, so depends for n, multiples if n not in multiples depends. But again, like we have repeated code here essentially, so there's got to be a better way for this. And how do we do this? I feel like there's got to be a way that we can just like stick in this generate multiples 3, generate multiples 5. Again, if anyone in the chat has any ideas, by all means, please let me know. Just trying to work it out in my head as right now. I can get to Googling in a second if I really want to. But this will work at the very least. So this does work at the moment. Oops, accept multiples, yes. And then we could say, then multiples, or let's do clear. And then we could say sum multiples, okay, sum multiples. And then we should be able to hit that. 2, 3, 3, 1, 6, 8. So is that what we actually need? Let's see, Project Euler. Solution. Just going on the internet here. There we go. So 2, 3, 3, 1, 6, 8. From what I looked online, that is correct. It looks like. So just showing, at least according to Stack Overflow. So why I'm disappearing here? Let's see. So 2, 3, 3, 1, 6, 8 is what we ultimately want. Now, I mean, it's good enough to get the right answer, but there's also things like, I guess, the efficiency of what we're doing in terms of like our algorithm and implementation and all that. I mean, I don't. I don't know, that sort of stuff I'm still kind of ignorant on myself. Oh, wait, here. So I went on Stack Overflow just to see 2, 3, 3, 1, 6, 8. That's what we need. And that is exactly what we got in our code. So going to our VS Code here again. I swear there's got to be a way to like really make this slick. Like do it in one line even. If not, I mean, not that that's like a virtue in and of itself, but just trying to think, because this is, you know, and this still works at the end of the day, but this is like repetitive code. This multiples is a bit, I don't know, it's just, instead of just using a line to like just to declare this, we could probably, with the declaration of this, I'm sure we could, I'm sure we could at least like do a little bit of work within here, like how we did for this function here, generating multiples. But who knows? I mean, don't want to spend too long on this one particular problem. We can, I guess we can kind of move on in a second. Well, this works. I just want to take a second to see if I can think of a better way, or two in the chat. I know we have, let's see. So let's kind of look through this. So initialize an empty list. So that's like what we have here, right? So this is going to be the list that's going to store, that stores all of our multiples. Calculate the highest number or the highest multiple of 3 and 5 on 1,000. So highest multiple of 3 times highest multiple of 5. Right. So so looping through numbers 1 to 1,000, range from 1,000. Right, so the nice thing is you can kind of bypass a little bit of that work just by like stepping by 3 and by 5. That way you don't have to do like any division or anything of the sort. We can just generate purely the numbers that we need. We don't really have to do any math. We just have to generate the numbers by counting 3 each time, or adding 3 each time, or adding 5 each time. And the nice way about this is that with this function here, we can just return this. We don't even have to make an array. We don't have to store it in memory. We can just generate it. If that's how it works, as far as I understand. Again, I'm still fairly new at that sort of stuff. I actually just started learning about data structures and algorithms recently. I've done quite a bit of like front-end web development and some JavaScript stuff for a while now, but I just never really got to the nitty-gritty of the data and data structure and algorithm side of things, and efficiency and storage and all that. So that is something that I'm new to. Anyways, check if the number is multiple of 3 or 5. 3, the numbers. Yeah, so that's the thing. It's like, this way will definitely work, it seems, but it's right. It's a lot of additional work because of what we're doing from the outset. Like this this explanation that we have here in the chat. It like we're generating all of our natural numbers, and we're I don't know. If we just generate only the multiples of 3 and only the multiples of 5 right from the get-go, definitely saves us some work and some additional code. And yeah, I guess that's the biggest takeaway. The number of multiples, I'm not sure if we had to print the number of multiples, but I think length would definitely be the answer to that. The length of the array. But yeah. So anyways, we got an answer that works. I will probably, maybe we can just drop this into ChatGPT actually. Let's drop this into ChatGPT really quickly. I'm just curious what it comes up with. Okay, so here's the ChatGPT solution. Kind of compare and contrast what it says. So find sum of multiples. Oops. Some multiple 0 for num in range limit. So the limit being 1000. Oh, okay. Well, that that is so straightforward. Wow. Yeah, that definitely. Man, modulo operator. Oh, that's what you were talking about, Jackson. Yeah. Like with the modulo 3, modulo 5. I need to like incorporate that into my intuition when I think about these sorts of things, because that's not like the first thing that I think about is using the modulo operator, even though it's like perfect for this sort of thing. It really is. Number is right. Right, and then you can just do or. I mean, it's so reflective of the language here as well, of just the initial prompts. So that's pretty crazy, honestly. What I also think is interesting is the philosophy of like where you put what would be variable in your program. So like when I designed this, if I can show it, let's see. So when I designed this, so generate multiples, multiple base, I made the base of the multiple the variable, right? That way the user could plug in, oh, because I zoomed in, that's why, right? Oh no. So with this, it's the, can you all see this okay, by the way? Should I have it zoomed in a bit more? put this off to the side. There we go. Okay, I think that should work. Well, still kind of cramped. Oh, no perfect solution, I suppose. Let's do that. Okay, that's better. So, so I had the multiple base. I had the base of the multiple, like be the variable, and then I had the 1000 as the, it's kind of like the static value within this. But what it did is kind of the opposite way, where it had the limit be variable, and it had the multiples of 3 and 5 be like the static values. So then, A, B, and you could go A, B, but it's like, to what extent do you want things to be variable? And like, does that even make sense for your program? That sort of stuff is interesting to think about. I think the proper solution for that sort of question is very contextual in terms of like what it is that your program should be able to do, what it needs to do, like every time, what it can be flexible on, so on and so forth. So there's no like ultimate right answer to that. But anyways, yes, very, very interesting. Man, I swear, modulo is insane. I love it. Anywho, so that's the first one. Let's go on to the second problem. So we have, let's see, share my screen. I'm going to go on to the second Project Euler problem to solve. Let's put it up on screen here. So this is problem 1. Problem 2 is going to be what? So each new term in the, what is that, the Fibonacci sequence is generated by adding the previous 2 terms. By starting with 1 and 2, the first 2 terms will be 1 plus 2 plus 3. Okay, so you just keep adding what? Oh, so 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. Okay. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even-valued terms. Okay, interesting. So some of the even-valued, so if we want to think of modulo, at least, even-valued terms would be, you could do modulo. What is even the terminology for that? Like, I guess mod by 2. If you mod 2 each term, that gives you the equal number. That would filter for like equal number or even numbers. This all makes sense once we kind of jump in. But if we mod each term by 2, we can get only the even ones. Values that do not exceed 4 million. Okay, so then I'm sure we could just do range for the 4 million. I'm sure we could do mod by 2 for the even value terms. Now we just have to think about how are we going to make it so that we add the previous number each time. And do we want to trying to think of the way that we would go about doing this. So I'd imagine that we'd want to generate all of the values first and mod by 2 to filter those values for only the even ones. And then we would add all of them up. Is that what we'd do? But then we'd have to have the logic of, so we'd have to have the Fibonacci sequence logic applied first. So we'd have to add all, so we'd have to apply that logic to get all of the terms up to 4 million. And then once we have all those terms, then we'd have to filter them for only the evens, and then we'd have to sum them all up. Okay, so I guess let's start writing this down. So if we go to, again, our handy dandy Microsoft Paint, we can jump in and start to think about how to do this, or we can start to make notes on how we're going to go about and do this. So open up Microsoft Paint now so we can take some notes. If it wants to load up here, there we go. Okay, so we have this here. So we are going to want to generate sequence. And we're going to want to do 4 mil. So we need the logic for that in place. And then we said what? Then we need to filter for even terms via mod 2. We just want to sum even terms. Okay. So then the question is, how are we going to get this Fibonacci sequence logic? How are we going to implement that? What would be the best way for that? So I'd imagine that you'd need, would we have to have 2 variables by chance? So one variable would save the last value, and then the other would just keep track of the total, would just kind of keep, the second would just be like the next term in the sequence. So you have the second variable would be the next, would be ultimately, it would go on to be the next term in the sequence. The first variable is the previous value. That way you can just, you know, add the first to the second. So I think that's the way to do it. But then how do you implement that sort of logic? Let's see. So if we start, so where do we want to start also? So let's say we start with 1. So we need the next value to be 2. So I guess we would have to, okay, why, that's weird. I can't type now. So let's say variable 1. We can initialize that. We can initialize it as 1. And then variable 2, we can initialize it as 2, I suppose. And then as we go along, is that how we want to do it? And then we'd say that, here, let's move this. Oops. So variable 1, we want it to, because these are our initial 2 terms. And the sequence only starts once we start adding variable 2 to variable 1. And we'd say variable 1 is equal to, plus equal to variable 2. And then we'd say variable 2 is equal to variable 1, right? So now this is equal to 3. This is equal to, oh wait, no. That can just stay as is, right? Oh, wait, no, yeah. So we want that to be equal to variable 1, which is equal to 3. And I think we can just loop through that, right? Because then we can say that, well, no, because that has to be equal to, hold on. Why am I losing my brain here? So we have 2, add that to 1, we get 3. And then the second time around, we can say variable 1, we want to add that. We want to add variable 2 to it, which gives us 5. Wait, no. So we don't want to assign variable 2 to variable 1. So now variable 2 equals 3, right? No. I don't know why this is throwing me for a loop. Again, anyone in the chat, jump in, save me from myself. Get all of our minds on this. So 2. But then how would we print thinking about, like, you know, how do we add all of these? I guess we could have it to where So variable 1 is equal to 1, variable 2 is equal to 2. For that first step, we can just have them be added, but it seems a little bit weird. I'm sure there's a better way to do it. Let's see. So 2 plus 1 gives us 3. Okay. So we add variable 2 to variable 1. Gives us 3 ultimately. And then we do variable 1 is, then we'd have to save it. I don't see how we can do this in steps, doing it this way. Because if we wanted to put variable 1 first, that would make it equal to 5. But then how would we get variable 2 to equal to 3 again? So that way we can add it to in the next step, So I think this is just, I think the way that I'm thinking about it right now is kind of doomed from the start. I don't think you can do it either way. Because if you try to do it, just kind of using weird delimiters here, don't mind me. But if we do it this way, where we try to assign variable 1 first, or we try to change its value first, then we can't, we won't have that 3 from variable 1 that we could assign it to because it just got changed. I think if we did it the other way around too, there would be an issue, because if we tried to do variable 2 is equal to variable 1, was it? But I think we'd lose that also. Unless I'm just thinking about this completely wrong. I don't know. I think we have some stuff in the chat that we can look at in a second. That'll, I think people are solving this better than I can off the top of my head. So 1, 2, variable 1 equals variable 2 plus 1, so that gives us 3. And we go, okay, well then how do we get variable 1, variable 2? Right, so then we'd lose that value of 3. Then if we tried to implement that in the first place, b equals 3. Oops. But ultimately going to equal 6. Yeah, so it doesn't work. So yeah, just from the very beginning. I mean, honestly, I feel like even from the very first assumption, it just didn't work. Saying that having two different variables, variable 1 to be the value of 1, variable 2 to be the value of 2. Then if you do that and you try to start off that way, then the question is, okay, well, how do you get the first value to be 1 and the first value to be 2 in the final list of terms that we generate? Because these two values are stored in different variables, and we ultimately want to return one thing for each of them, doesn't really make sense to do it this way. So with that, let's try to think of a better way. Let's see. So Fibonacci limit generates Fibonacci numbers up to limit. A B equals B, A plus B. A B equals 0, 1 while yield A. I'm not entirely, I don't know how to interpret your notation of it. I mean, I say that I was using my own little weird system. It's not going to go, but I can't off the top of my head interpret your notation of this right off the bat. But we have variable A, B equals 0, 1 while the limit. So the limit that we can put in is 4 million. And we can return A equals B. I don't know. I think I'm getting a sense of what you're getting across though, Jackson. So let's see. So instead of using those two variables with different values, it doesn't really make sense. if we do A, yeah, I like A and B better, actually. It's a little bit less confusing. A equals 1, so you said B equals 0. So if we do, A, so we could do B equals A, which would make it 1. I guess that makes this one redundant, but I don't know. So to limit things, just kind of show that what's going on the right-hand side. You could say that A plus B, so B equals 1, A equals 2. And can we keep going like that? Could we say that B equals A? Oh, okay. I think that's the way to do it then, right? I guess we'll see. Whatever, this works. So B equals A, B, and we can just keep, actually, let's make this a little bit smaller maybe. That way we have more space to work. So we have that. So A equals 3. Oh, but then do we get caught in the same trap then? I think we do. Oh, this is so annoying. Wish we could do like, here, let's do this. There we go. Now we have more space to work. So we don't even need this B equals 0. Just say that B equals A. So and that should get us going. So B equals A, B equals 1, A equals 2. You could say that it's 2, 1, 3, 2. B equals 2, A equals 5. Right? No. What am I saying? Equals 1, A equals 2. So for this, I guess we could say it's like 1, 0. B equals 1, A equals 2. So 2, 1. And if we add that, though, that gives us 4, right? So I guess that doesn't really work either. So then how would you do this? I don't want to spend, maybe we'll spend the next 5 minutes trying to figure this out. So maybe could I swap these around? Is that the way to do it? If I make this 1, 1. Is that how I want to do it? Let's see. Just tinkering at this point. No, because you'd still get 4 from that. So what am I talking about? That still won't work. Oh, I don't know why I'm not getting this. I guess I'm not really, I don't know. I guess I'm just on the spot with it. So A equals 1, B equals 1. Plus B. Oh yeah, because they're just, I guess there's no real reason to really have the B if I'm just setting it to A, because I just have A, and then A equals A, and I don't know. Let's kind of start from the beginning real quick. So we need 1, 2, 3, 5, 8, 13. So A needs to equal 1. Then A needs to equal, so A plus X gives us 2. A plus X, A equals 2. So A equals 2. So could I just do that where we go A equals 2, A plus X equals 3, A equals 3, and then A equals 3, A plus X equals 5, A equals 5. Just kind of playing around with things at this point. So X has to equal 1, X has to equal 2, X has to equal 3, right? So it has to equal the previous one. So now I'm just treading on ground that we already know. So then how do we just capture this value of the previous one? Because it's weird, like there's no, like I'm trying to think if there's a pattern, like if there's a loop or something that we could do, or if there's something that we can manipulate to capture like the value at each stage, but I just don't really know what that would be. Because it's not like it's going, I don't know if linear is the right term, but you know, it's not like scaling multiplication wise or anything like that. So I don't know how you would progress in that way, because it seems maybe the term is nonlinear. Again, I'm still pretty rusty on my math, building myself up with it. Again, anyone in the chat, definitely drop things in. So A is equal to A, B is equal to B. Is that, well, A is, right, A plus B. But I don't understand, like, of course A is equal to A, of course B is equal to B. Then how do you capture the difference between each and every value? Because it's not arbitrary in terms of how they progress, but it kind of feels arbitrary in and of the moment how you have that go. So worst case, again, we'll just find a solution. Like if I can't figure it out in 2 minutes, then we'll find a solution. We can just keep going forward. So A equals 1. I need to plus X, which is equal to 2. So I need to add 1. I need to add 2. I need to add 3. Then I need to add 5. Then I need to add 8. Oh, I just can't wrap my brain around it at the moment in terms of if there's like one like system or one neat little thing to write that would do that. We have, this is plus 1. This is plus 1, plus 2, plus 3, plus 5. So you're just adding. This is kind of the oddball one too, because, well, actually, no, hold on. Can we like reverse engine? Can we like go farther back? If I say 1 plus 0 equals 1, trying to see if we can like go like, could I do that where we say 1 plus 0 equals 1, and then I don't know if that would work though. Yeah, because the logic I feel like starts right here. I think there's 1 step to 2 arbitrarily, and then you have 2 plus 1, it gives you 3. 3 plus 2 equals 5. I know you're dealing with the natural numbers though. Anyways, I don't know. We thought about this quite enough. Let's just see what solutions already exist out there. Let's go in Python. Write simple Python code to generate Fibonacci sequence. So we are going to say okay, so it looks like there is some code for it. So let's understand what exactly is the way to do this. Okay, so here we're in our code. Let's make a new one or a new file. Py2, Py. So here's what ChatGPT spit out. I actually love ChatGPT because for stuff like this, because you can just use it as like a coding mentor in a way. At least, like I guess for simple code, you can get a high quality solution that you can learn from. So okay, well, interesting, because so you have this like ordered pair of sorts that you can interesting. Okay, so is it not? Let's see. So generate Fibonacci sequence. So we have an array of 0 and 1. So what is, we have number of Fibonacci, set the number of Fibonacci numbers to generate 10. Actually, let's print it out and see what it says. 1, 2, 3, 5, 8, 13, 21, 34. Okay, so it is kind of weird at first, right? 0, 1, 1. Well, I guess not weird. It's just, it's interesting because I was getting at some of these things just a second ago, right? I was wondering, okay, well then what happens if you start from 0? Okay, well, or what happens if you just, that step from 1 to 2 seems kind of arbitrary at first because it's, it starts when you add 2 to 1 to get 3. Let's see. So if you have 1 and you add 1 to 1, you get 2, right? Okay, so let's walk backwards. So if you have 1 and you have 0, you add 1 to 0, then you get 1. Okay. So the Project Euler issue didn't start from that. It didn't start from 0. It started from 1 to 2 to 3. I think that would have been helpful if it gave a little bit of that, if it gave that sort of context. Let's see. So let's put this in our thing here. Oops. Here we go. Okay. So anyways, yeah, so it's interesting because we touched upon quite a few of the different aspects of this just by trying to figure out what exactly was going on. So these are the first two numbers then. So 0 to 1, that gets you going. So I wonder if it has to be 0 and 1 span. I'm sure you could start with any two terms, right? As long as they have the proper relationship in the Fibonacci sequence. So in fact, let's try that out. So let's start with 2 and 3. Let's see if it gives us the same thing. Yeah, it does. Okay, it continues on normally. So it's not the starting point that matters, it's the logic, which definitely makes sense because, of course, in a Fibonacci sequence, in any sort of sequence like this, you can you don't have to necessarily start at the beginning. You just have to follow the logic all the way through. So a length and Why would it use negative indexes here? -2. So now I'm curious what exactly this does. Let's comment these out, so that way we can, well, actually no, we can do that. Let's do prints. Pip sequence, -1 is equal to, let's do this. Let's see what that gives us. 1. Okay. Oh, okay. I guess just to format it more. I guess maybe just to make the formatting, the readability of it a little bit more intuitive. Right, because I was going to say a negative index just reads it from right to left instead of left to right. So why would they do that? I guess it's just for readability. Yeah, because it's just this plus that, this plus that, this plus that as you go through it. So then what exactly makes this so difficult? Why was I not wrapping my head around it? Fibonacci, next number equals -2. So what am I missing here? Did I just completely, is this like the easiest thing in the world and I just completely misthought about it, or what? So 1 plus 0. You append that. Oh wait, you pass a number to it. Okay. So that number is the, isn't that? Yeah. So then what am I missing here? How do these values get updated then? Because isn't this just always this one and always that one? Oh wait, fib sequence. Oh wait, no, it's getting a, oh, okay. Okay, I see what it's doing. Okay. That's actually really, that makes sense as to why it's using these negative indexes then. Wow. Okay, that actually is pretty, so what's happening is that, so it starts out here. So it goes 0, then 1, and then it goes, then it's going to append. Right? This appends to this Fibonacci sequence here. So it's going to go, it ultimately gives you this next number, right? It's going to give you this plus this. It gives you 1 here, and that gives you, and then now with the array, now this -1 is going to refer to this value. This -2 is going to refer to this value, because the -1 always refers to the last value. -2 always refers to the second to last value. So now next time through, it's going to add this and this, and it's going to give you 2, and then 2, 1. Oh, so using an array for that, that's actually so smart. I was wondering, like, how do you do that exactly? So I wonder, I think I deleted my code for it accidentally. Did I even? I don't think I even wrote any code for it, did I? I can't even remember at this point. No. I did not write any code for it. I had it in my Microsoft Paint. So let's do that. Let's see where I went wrong with that. Or let's see, now that we know how we can possibly do this, like what exactly failed in my conceptualization of it at first. So I said that before I had the idea of the 2 variables, right? Like A and B. So where does this fail in terms of not being able to track the information properly? So I had A's 1, B is 0 originally. So I actually had this. So even though the starting values are correct, right? A, so we had B here and A. I kind of just had it as like an ordered pair, like A, B. And so what I need to do then would be, okay, so I think that's where I went wrong, is that, or what? Well, even then, this should work if I just started from 1 and 2, right? So it should have been that A equals B. So A is equal to 3. Then B would have to stay the same, right? So something with how the information is being stored that's just not working in this. I don't think there's not like an absolute. Well, it doesn't necessarily have to be. I was going to say at least the array is like an absolute source where it can kind of exist outside of this pattern here. But even then, I mean, you don't have to have an array that stores like every step of the pattern, as long as you have the logic in place of like, you take this thing, then you add this, then you take the previous thing and add it again, take the previous, add it again, take the previous, add it again. So you don't need something to like store that and like have it be set in stone. You just need that. You just need that logic to it. So, so what am I getting wrong here? That's what I don't understand. I don't know. I think I'll revisit this on my own time, just kind of get it down. Because again, like I had started with that like 1, 0, but even then, like you don't have to start at 0 because you can start at any you can start at any point in the Fibonacci sequence. You can start at any value and just still continue that pattern. So, yeah. So if A is equal to 1 and B is equal to 2, I guess we should maybe swap it around. Would that matter? A, so that would mean it's equal to, right, B is equal to 3. But then again, like how do you assign, now A can't be assigned to 2, which is what we need to do. But if we assign A to 2, then we can't, then we just get 4. Like, what am I missing here? I don't understand. Anyways, I will tackle this on my own time because we kind of have we get the gist of what's going on here. That's just annoying to me. But with that, let's finish the rest of this program. So we have the Fibonacci sequence generated. And now we just have to sum the values, the even value. So it said that do not exceed 4 million. So we need to do, well, set the number of Fibonacci numbers to generate. So does not exceed 4 million. So that's not exactly right. I'm saying generate 4 million of the instances of the terms in the Fibonacci sequence, not the values themselves up to 4 million. So that's not exactly right. So is there a way that we could modify this to make it so that I only get values of 4 million? I guess we could do it kind of lazily. I mean, you know, not lazy, but we could just say that maybe we could say and fib sequence -1 is not equal, or not, I would say is 4 million. Oh no, let's just do this. That's the way to do it. Equal to 4 million. Then we just get rid of this. I guess that works. There we go. Okay, so saying all Fibonacci sequence is less than or equal to, yeah, do not exceed 4 million. So it can be at 4 million. I'm not really sure what it does around 4 million, but we can see. Fibonacci sequence. So now if we run this, we should get, what's going on? Oh, M. I don't care about that. We don't need that anymore. What is that? 100,000 million. So we have one value too many. That's still going to be the same thing. I don't want that value in there. So what do? Well, it's going to stop at, right, this form. So it's not going to be triggered unless we get this value here. So what do? The sum of even is, I guess we'll see. That's what we're going to try and find out. It's good that you said that though, because if that is the right answer, then I'll just use that as my thing of comparison. So I guess we want it just this then. We do that. No, what am I doing? -1. Oh, how do we do this? I guess we could do, again, this is probably a little bit janky. Next number is do we want to do that? Do break. Try this. Oh, what the heck? Oh, if it's less, yeah. There we go. This is what we want. There we go. That fixes it. Again, I'd have to think that over to see what would be the best way to implement that, but that works ultimately. And so what we want to do is, so we have that in place. We want to do sum for n and generate. Can we do this? Let's see. Fibonacci. Fibonacci. Does that work actually? Not defined. Generate Fibonacci. What do you mean it's not defined? I didn't spell it wrong, did I? I did spell it wrong. Okay, well, let's see. Let's see if this works. So that's still running fine. So can we do prints 22? I feel like that's not right. Oh man. Let me do this. Okay. So let's kind of step back here. So we do get that. Well, no, I mean, there's not really a lot of even numbers in there, are there? Well, even then, it's like, I mean, there's 3 million something that's even. This. Okay, so I'm guessing that just adds everything up. Okay, so that's not the proper way to do it. So n mod 2. Oh, wait, okay. Oh, that's modding everything by 2. Okay. So I wasn't checking for if something was even, if it was mod by, I was just modding everything by 2. That makes sense. So if we do this, oh no, what? What? N for, let's say, if n mod by 2 equals 0. Is that what we need? No. What am I doing? Why is this not working? Syntax stuff. Oh, then this is just going to return booleans, isn't it? So that's why you get 12, because there's probably 12 of those numbers that it makes sense for. Because this is going to return a true or a false. And a true is a true is equal to 1 as an integer. False is equal to 0. So there's probably 12 even numbers within here. Even though this is like not, even though we're having like, even though this is having some difficulties, it is still kind of interesting because it's just unveiling different parts of just how code works. Yes, you need a sum of even terms. Yeah, exactly. But what I'm trying to do right now is I'm trying to figure out a way to filter for my even terms. So what I'm trying to do is having it where I'm trying to generate an array, or I'm trying to, not, array is a JavaScript term. I'm trying to generate a list of the even numbers from the Fibonacci. And I'm trying to generate that by, for each value within it, seeing if it's even. So I have the concept down. I just don't know the, if n is maybe that. No. Let's see. I'm gonna go over to the good old ChatGPT. That should be it, shouldn't it? N for n in, oh, okay, so n for n in the Fibonacci sequence. If, there we go. Okay, so this should work. 461. Okay, there we go. And there we go. Just as you said, Jackson, it's 461 3732. So n for n in generate Fibonacci, if n, there we go. That's the slightly annoying thing, is you know what the logic is supposed to be, but it's just implementing it properly in the code. But now we did that, so now it's good. So that was interesting. So yeah, I think the most annoying part about that was just figuring out how to generate the Fibonacci. I had some sort of misunderstanding in how to execute the logic of that, but I still don't exactly understand. I mean, I understand why this works. I don't really understand why what I was trying to do before doesn't work. I'll have to sit down with it and I'll have to sit down with it and try to understand it. It's just Python semantics. Yes, exactly. It's yep. Like you just have to know how to implement it, like in the coding language too, whatever it is that whatever concept you have. Like I said, I like, 5 minutes ago I had the exact right thing in mind. For each value in the Fibonacci sequence, if you can mod it by 2 and get 0, then add it to our list of numbers to sum. But this is the way to actually implement it. And for n in general Fibonacci, it's still kind of weird. Like I know this is what you're supposed to do, like intuitively, but I don't. N for number for. Okay, so return. So I want this ultimate. So this is the thing that I ultimately want for each item in the generate Fibonacci sequence, and I will get this from this and all the individual items if this is true. Okay, makes sense. So let's go on to number 3. We have about 30 minutes left. We'll see if we can finish this third one. These are fun so far. I actually quite like these. Jackson, you're the one that's most. You've actually been giving a lot of good insight into how to do this, but I haven't shown everything on screen yet. But you actually have been pretty helpful in that. Have you done these before yourself? These are pretty fun. I actually like these. Getting me thinking. But with this, let's go ahead and look on to the next one. The prime factors of 100, was it 131? No, 13,195 or 5, 7, 13, and 29. What is the largest prime factor of number? Oh my goodness. Oh my goodness. I'm going to have to refresh myself really quickly on prime factors. So prime factors are numbers that can only be divided by themselves in 1, if I remember correctly, right? Prime factor is a natural number other than 1 whose only factors are 1 in itself. So then what does it mean that, so the prime factors of 13,195 or 5, 7, 13, 29, what does that mean? How can one number have multiple prime factors if unless those are the numbers that you, oh, so those are all the numbers that you multiply. Oh, okay, this is ringing a bell. So if you multiply 5, 7, 13, and 29, you get this 13,195. But like you can't break these down anymore, right? You can't break 5 down into any other factors. It's only that's 1 times 5 is the only thing that will get you 5. Right? 2 times something, none that can never get you a 5. 3 times something that can never get you blah 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 blah. So oh man, I'm gonna have to pull up my arithmetic notes really quickly. I haven't done this sort of thing in a while. Like deduce. What do you? I remember doing factor trees. I'm gonna have to do that now. Let's see. The ways here, I'll share this. These are my personal math notes. Because again, I've been teaching myself math again from the ground up since the beginning of the year. I'm going back to school for computer science, and I never paid attention to math class when I was younger, even elementary school. I don't know why. It just never, just annoying to me. But now going back to school for CS, it's like you have to know your math. I completely forgot it. I forgot everything, assuming I even knew it in the first place. So I started teaching myself math again. So now I'm up to high school math, about to take a college stats class, and ultimately plan to get up to calculus by the beginning of fall 24, like worst case. Let's see. So ways to find primes, start working with the smallest number, break number down into any factors you can, use a factor tree. So, oh man, do I even want to try that? I feel like there's a better way to find your factors. Is that, oh man, what did I swear I've read of a system. I think it's like a Pythagorean way to find factors. Pythagorean factor. Maybe I'm thinking of the greatest common factor. I think there's something in like basic computer science, like mathematical concepts like that. Maybe it's Euclid. Maybe it's not. Maybe it's Euclid factor, greatest common factor. The Euclidean algorithm is an efficient method for computing the greatest common divisor of two integers. I don't know if that would be something that we would need here, but I'm just kind of throwing things out at this point. Yeah, exactly. It's such a big number. Well, let's see. We can try to break it down. Oh man, I'm sure there's a more. Well, I don't know, because like these aren't crazy difficult problems just yet. Like problem number one, like of these Project Euler issues, like the first two really weren't bad. It was mainly just like trying to figure out how to implement them coding wise. But this one, let's see. So let's try a factor tree really quick. We'll see, as long as it doesn't take a million years. Other than that, I don't know what you do to. That would be kind of interesting. That's an interesting thought, actually. Like, how would you write a program that could find factors, that could find prime factors? I don't even know how you would do that off the top of my head. I'd have to think about it. I guess you could check if you could mod it by what though? Because the only things that it should be able to be modded by are like one in itself, right? And in order to like return 0, I mean. Let's see. So anyways, so here we have this. Let's jump into Microsoft Paint and see if we can figure something out. So we have Microsoft Paint. We can actually, let me kind of want to save what I did before. Let me make a new instance of Paint. We'll use this to try and figure this out. Oops, the windows all just minimized. Let's do Paint here. Okay, so let's see. Oh man, what is this number? Let's see. So we have 100,000 million billion 6 billion something something something. So what is it? So this is, what do I even want to see? I want to see if it's divisible by 3, because 3 kind of has an easy one, that easy divisibility rule. Obviously not divisible by 2. It's not divisible by 5 or 4 or any of that. Not divisible by 6 because not divisible by 2. Divisibility rule. So let's see if it's divisible by 3. So well, I guess it wouldn't be divisible by anything except for Well, actually, no. It would only be divisible by 1 in itself, so is that even worth checking? Like, what do I even do? How do I even begin to approach this? Anyways, I don't know. We can try. I mean, it should only be divisible by itself in 1, but whatever. I'm going to try the 3 divisibility rule. 6 plus 8 plus 5 plus 1 plus 4 plus 7 plus 5 plus 1 plus 4 plus 3 equals 44. So now divisible by 3. Yeah. So it should only be divisible by itself in 1. Man, then what do you do? How do you even make a factor tree for this then? Because it's like a prime number. How do you make a factor tree for a prime number? Because even if you take this like 13195 and you try to, you know, try to factor things out, 13195. Wait, no, I guess no. I guess you can no. I guess it is divisible by 5. That makes sense. Divisible by 7. Divisible by. So it is. So it is divisible by these numbers. So then, what do you do? I guess thinking of our approach towards this. If anyone in the chat has ideas, please throw them out. Definitely looking for this to be a collaborative process. But I guess my first question is there a way to write a program that can just find prime factors in and of themselves? And if so, what sort of process would you have to undergo to check if something is a prime factor or not? So I guess you would have to check if it's divisible by all of the natural numbers up to that number itself, right? So let's say I had, I don't know, so you have to be, I guess for n, for number n. Why is it doing that? So for n, you would have to check if n is, I guess for range 0 to n, you'd have to check if n what am I trying to, so for I in range 0 to n, to check if n is divisible by that, right? And if it is, so if it is, and I guess you return like then it's not a well. So what am I saying? So I guess this would find if something is a prime number. But we're not trying to find prime numbers here in and of themselves. We're trying to find the prime factors of a number. Well, this could be a first step towards that, no? So would 0 and 1 be omitted as potential denominators? Denominators, like in terms of, could you expand upon that, like in this context? Well, I guess, yeah, because if we have, I'm saying, so something is modded by 1. Okay, I think I see what you mean. Yeah, because that denominators is basically just is what you're modding by as well. It's just that you get the remainder from it. Well, if you mod by 0, you get... Oh, right. Okay, I see what you're saying. Right, so you wouldn't want to use those. That's perfectly good. Right, so mod by 2. That's actually a good point. Okay, so for 2 and onwards. So if n is divisible, you would return false. Otherwise, I guess else return true. Is this making sense, like what I'm saying here, everyone? If I'm completely off the mark, please let me know. Just the stuff that I'm trying to work out here. And if this is, like you just did, Pharaoh, that was definitely a good catch. Yeah, because like everything's mod, like you always get 0 if you mod by 0 or 1. Right, exactly. We're all in this together. That's for sure. These are fun though. I actually really like this. I really like this. So for I in range of 2n, so this would give us, so I guess this just checks if a number is a prime, right? Like check prime. But it's like, okay, well, how do we do that? So then what do we do to check, to apply this? Is this even relevant to what we're trying to do? Because ultimately we're trying to get the prime factors of this. Well, okay. So what we could do is that we could then generate prime numbers up to a specified range. So we could generate primes up to this value of 600 billion, whatever. So then we'd have all the possible primes that could eventually fit within this number here, right? So generate prime numbers for I in range 2 up to here. And then for I in range 2n, if n is, so I want to get an array of this, of all these in the end. I want to return an array that has all the prime numbers within it. No, not 1, but I. Yeah. Is this even making sense when I'm typing out though? Because eventually this has to have, like, what are even the prime numbers? What, like 1, 2, 3, 5, 7, 13, right? 11, 13, something like that. I think 17. That's what I want to get in the end. So generate prime numbers for I in range this. Where's my brain going wrong here? Well, we got about 15 minutes left. If I can't figure this out within like the next 30 seconds, then we'll generate some code that will generate prime numbers. If n is Well, this have to be. I think I might be completely thinking this, or like the way that I'm thinking about it and the implementation that I'm theorizing here are just like not adding up. So we want this like 6 million, whatever that we're putting in here. We want to test it for like every natural number to make sure that it's not divisible by any of them. So for n, so then what do we do for I in range 2 all the way up to, I guess all the way up to n minus 1, right? Else return true. And then if this returns, and then whatever returns true, or we either return I or we like append I to an array, right? And if n, so then eventually like we'd get this sort of array, right? I think that would work. But anyways, I don't know. Let's generate some code. So let's say write Python program that generates. I keep saying array, but it really should be list of prime numbers up to a user specified limit. You can. Oh my goodness, ChatGPT just like dropped this ancient algorithm for calculating prime numbers from the early 2nd century. It's called the Sieve of Eratosthenes. This is insane. In fact, yeah, what that's actually what a Jackson looks like. It's similar to what they put in the chat. That is so interesting. So here, I'll take the ChatGPT code and put it in here so we can all see. Where's my VS Code? Here. So let's go Python 3, or not Python 3, problem3.python file here. So this might take a second just to like unravel in the first place. Let's see. So create a Boolean list is prime and initialize all entries as true. So zero and one are not prime numbers. Oh, okay. Oh, okay. So it just sets up the. Okay, that makes sense. That makes sense. So, like these are the ones that are not going to follow the pattern. So, iterate through numbers starting from 2. Well, there we go. I mean, this is similar. It's kind of similar to what we. Were getting towards, right? We talked about like in range 2, right? You don't want to start with 0 or 1. So if is prime number, okay, so then what's for num in range 2? So if is prime 2, for multiple in range, num times num plus 1 num. It's going to take me a second to kind of wrap my head around, honestly. So the first number, so can we begin at the number of interest and work backwards? So we can start from that 600 million. The first number working backwards, which is prime, would theoretically be the largest prime number. That's true. But it's, I guess from there, like how would you start from that 600 million and then work it backwards to a prime? Like how do you start from that arbitrary number? And that, because that number could be prime or it could not be prime, right? Your starting point, because it's just kind of an arbitrary number. So how do you go from that and work backwards to the nearest prime? You see what I'm saying? Like, I wonder how, like, could you even do that? I ran the code of VS Code and gave 29 for the first half of the problem. There are probably 6 or more ways to do this mathematically. Run a prime check on each number from the number of interest. Working backwards. Oh, okay, I see what you're saying. Right. But then it's, right. Yeah, and I guess, again, the prime check would just be if you mod it by all these, do you get 0 or not? And if you don't get 0 for any of them, then up to it, then it's that's a prime number. So get user. So what exactly? So what I'm not understanding here is, well, let's see. So let's run this. We actually haven't done that yet. Let's say 1,000. So here it does do all this. Cool. Cool, cool, cool. So then how does this actually work then? So is prime true times limit plus 1. But why do you have just this list of just true? Okay, false, false. I don't know, like, what is that supposed to be representing? And you set the first 2 indexes anyways as false. So are these all of the natural numbers? Like is each index of the list, like is 0 supposed to represent the number 0? Is 1 supposed to represent the natural number 1? 2 the natural number 2? It looks like it if you have limit plus 1. So why would you want Boolean? Why would you want a list for like every individual? Because if we have 6 million numbers, and you'd have a list with 6 million indexes, all for each natural number. But well, I guess that way you have an easy reference, maybe, where it's like, is prime, then you just type in the number, and then you just see if that index is true or false. But that's just, it's like, why wouldn't you just calculate it? I thought memory, like, I don't know. Like from what I've learned, at least the little bit that I have, it's like usually you should like calculate stuff like that. So what's the big deal? Or like, so what is happening? So integer limit times, I wonder why you have it. Oh wait, no, you don't have it. You put it to the power of 0.5. What does that do? So I put 25 times 0.5. Oh, you get the square root of it. Is that it? You do. Okay, so why would you want the square root of it? So the square root of that plus 1, if is prime number, mark multiples of num is not prime. Yeah, I'm gonna have to sit down with this and really pick it apart just to understand what's going on here. Because just like right off the bat, it's not exactly intuitive, at least just jumping in and like trying to figure it out on the spot. I have to sit down and try to reverse engineer this stuff. Times num. Prime numbers, num for num in range if prime number num. Okay, return prime numbers. I mean, it works. Now we have our prime numbers. So we just said that once we have our prime numbers, I guess we'd want to see if it's divisible by any of the prime numbers. And then, well, if it's divisible by the prime numbers, like if there's an amount of prime numbers that it's divisible by, how can you tell if those are the prime factors though? So say you have this number and you find that there's prime numbers that it's divisible by, but is it really the case that if you take all those prime numbers and you multiply them together, would you automatically get, the number that you're aiming for? I don't know, definitely interesting stuff. Definitely interesting stuff. Those are random primality tests, factorization method. I'm going to take a sort of interesting. I'm going to have to take notes on all these different mathematical things that you're listing here. Primality tests, Brent Pollard. It's funny because I did web dev for a really long time. For about 1.5 years, I learned it. Just kind of straight HTML, CSS. JavaScript only so far as to like add functionality to web pages. And then some like React and like Next.js. And I did not really care for all that though, I learned. Even though I spent so long on it. I mean, it was kind of exciting to learn it. It was kind of cool seeing stuff being made, but I don't know, like learning web pages didn't really seem that interesting, or making web pages just did not seem that interesting to me. Because it just feels kind of like, what's the word? I guess arbitrary in a sense, in that like learning how to make web pages kind of just exists within that realm. Like learning how to make front end stuff just kind of exists within that realm, like just making front ends. Now, of course, like going deeper, there's principles of UI and UX that I think apply to many other different disciplines. But I don't know, like just learning HTML and CSS and enough JavaScript to make interactive interfaces kind of just felt like that was its own little world. Whereas this sort of stuff is so interesting to me because I don't know. I just feel like you could solve, I mean, these little math puzzles kind of exist in and of themselves in a way, but I feel like you could take these sorts of principles behind them and just apply it to so many other different fields and methodologies. I don't know if hope this is making sense what I'm saying, but I don't know. I just love this sort of stuff. Can you run a list of prime numbers up to our number of interest, then working backwards, try to see which one is the first factor of the number of interest? Number of interest. Definitely stuff to delve into. So we're actually reaching the end of the stream here. So unfortunately, we're going to have to stop for tonight. This is super fun. I mean, I recommend everyone to dive into these themselves. And too, like in the MLH Discord and everything, like keep us updated on how you come across or how you come along with these. I'm definitely gonna be delving into these a bit more myself. I don't know if they're too practical in terms of like. There's probably other things that take priority in terms of programming, at least from what I read about. Like these aren't like super like gonna turn you into a crazy programmer, but they definitely get you thinking. I like the problem solving like mindset that they put you into. I think that definitely is helpful. Probably has some wide appeal. I mean, you probably don't want to do this like, you don't want to make like this like your main thing, but certainly gets you thinking. It certainly is fun. I think it's perfect for something like this. Actually, every 2 weeks on, wow. Yeah, this is like pretty crazy. And that's the thing, like so Project Euler goes really far. I think there's over 100 different problems, and it's supposed to get even crazier and crazier and crazier. So yeah, thank you very much, Audrey. I appreciate it. Definitely some fun stuff here. Thank you all for watching and being part of this. So there we go. AI helped us on the first couple just for making optimal solutions. But okay, we are at the end of the stream here. Thank you everyone for tuning in. We will, I appreciate you all being here, and we'll just bring things to a close now. Thank you, everyone.